So we want to talk about today applying slope. Okay? So we're going to work with slope to graph lines. I feel like when I start talking, somebody else starts talking. When I'm talking, you're not talking, okay? Alrighty. Let's review what we know about slope. It's the ratio of vertical change to horizontal change, right? Vertical change, which is a change in y, over a horizontal change, which is a change in x. We use a formula. That's that delta y over delta x, change in y over change in x, y2 minus y1 over x2 minus x1. Positive slopes rise. Negative slopes fall. A zero slope means there's no tilt at all to a line, yet an undefined slope is the tiltiest tilt we have. We can't get much tiltier than straight up and down, and we need a big number to apply to that. We don't have a biggest number, right? So it's undefined. And we use slope to help us analyze real world data. That was rate of change. So we worked on that last time. Just a quick review. Positive, negative, zero, undefined. What's this guy?
Negative.
It is falling, it is negative. Positive, negative, zero, undefined. This is where if you try to ski on this thing, it's flat. Positive, negative, zero, undefined. This one, if you're trying to ski on this, you need some other form of power because gravity's not going to help you. And then positive, negative, zero, undefined. Positive. Going up. Right? So you're always kind of thinking about traveling left to right. Yes, sir. This is just review. So this one's not on your notes yet. This is on last one's notes. Again, review. So it's not on your notes yet. So you're going to plot the points and draw a line. What's the slope? So if I go 1, 0, and then I go 5, 1, 2, 3, and I have this line, right? What's the slope of the line? Well, I can use the slope formula, which is y2 minus y1 over 5 minus 1, that's x2 minus x1, and I get, what, 3/4? Okay, now this is what I was trying to explain earlier and not doing a good job. Yes, use the formula, no problem. But if you have a graph, pick 2 points that are, I'm trying to use the right word here, their x, y's are integers, meaning, please stop talking over there right now. So you pick 2 points on the line where the x and the y are integer numbers, and not like a half or something like that. So I wouldn't pick like this point in here or like a point over here. I want to be right on like the crosshairs. And then what I do is I say, how do I get from here to here? Well, vertically, how many up would I go? 1, 2, 3. That's my change in y, going up 3. Up is a positive direction. How about how many do I go right? 1, 2, 3, 4. Going right is also a positive direction. There's my slope. It is much easier. Now you could also start from here and go down. So watch what happens if I do that. So start from here, I have to go down 3. Now going down is the negative direction. And then I go left 4. Going left is the negative direction. What is negative 3 over negative 4? 3/4. So it's another way of doing slope with, I think this way's a little error prone if you're having trouble adding the negatives and all that. So you can always just count the boxes. Let's look at this one. Negative 3, negative 2, I think that's over here. And 5, negative 2. Oh, okay, what's this one? 0. Right? You have a nice flat line there. So that slope is 0. And then this one, negative 1, 1, negative 1, 5. This is an undefined slope. Any of you who use the internet to help with your homework, you might find places where they say no slope. This is what they used to tell us back in the dark days when I took algebra. It has no slope, which is true, but it's really an undefined slope because you're dividing by 0 if you would use this. Look at the x's, negative 1 minus negative 1, 0. Okay, so we're going to find the slope of this line. Again, more review, so let's use that new way. So I look for where it's right on the crosshairs. The next one looks like it's right here. The only issue here is it looks like I'm counting by 2s. So when I'm counting up, 2, 4. Yeah, I'm really going, I'm not going up 2, I'm going up 4. 2, 4. Up. Up positive, right? That's my M. And then how many to the right? 2, 4, 6. So reduce it to 2/3. There's my slope. Always reduce. Always reduce. If you're figuring out a slope and let's say it comes out to 3/1, do you leave it as 3/1? No. What's the slope? It's 3. Okay, that's what I mean by simplest form. What happens if you're doing it by you have 2 points and you get something like this? 0. Now what if you're doing 2 points, you work it out and you get that undefined. Yeah. That's simplest form. Yeah.
But if we get like 2/3, do you want us to divide it with?
No, leave it as a fraction, and we're going to find out today why it's so important to leave them as fractions improper. Yeah.
Is there a way to tell if something is undefined, like when it's before it's plotted?
If your x's are the same value, it will be undefined. Here, yeah, let's go back to that guy. See how my x's are the same? When you subtract same things, you get 0, which means you're changing x over to 0, which means you're divided by 0. So if your x's are the same, good.
If your y's are the same, it's 0.
If the y's are the same, you have a slope of 0. Yeah.
On a test, if we saw something like that, could we just write undefined and do the extra?
I think it's okay. I am okay if you're noticing, listen, this is straight up and down, it's undefined. That's where I want you to be. So I'm okay with that. Unless you're wrong. In which case, showing work is always good. But you won't be wrong, you know that. All right, now we're going back to the notes. That was all review, and you guys seem like real strong, which is nice. So, standard form. Do you remember this? AX plus BY equals C. I'm pretty sure we talked about that. Standard form of a line. This was handy when you were using the intercepts, find the intercepts. Remember you said y equals 0, find x. Find the y-intercepts at x equals 0. We did that. And standard form, the A to B to C, they're placeholders for numbers. So an example would be something like, that, right? That's an example of a linear equation in standard form. Now, I want to put standard form into function form. Do you remember what function form is? Y equals, solve for y. Now, some of us had a little trouble with this on the last test. So really stay with me. This might help you a little bit if you're still struggling with it. I'm going to take ax plus by equals c. I'm going to solve it for y. When I'm all done, I want y equals. Now, all this does is it's just kind of rewriting this. It's still going to be a line. It's still this equation written slightly differently. So somebody tell me here, if I want y by itself, Brian, what's that first thing I need to do? Subtract the ax from both sides, right? Because ax minus ax is 0, and I'm left with the by here. And I could write it as c minus ax, but I'm going to do something slightly different here. I'm just going to write it as minus ax plus c. Can I do that?
Yes.
Right? Because this is really a positive number. I could either write c minus ax or minus ax plus c. You guys with me?
Yeah.
I don't know what's going on over here. You guys really need to be paying attention. Now I want y by itself. So what do I do now, Matthew?
Divide b.
What gets divided by b?
Everything.
Everything. Everything. So I divide this by b, because why am I dividing by b? Yeah, because that becomes a big one. I have one y, that's what I want to have. But dividing everything by b means I'm doing this. Whoops. I did not write so up here. So what do I have? Let me see. I get y equals negative a over bx plus c over b. So this and this are the same thing, just written in two different ways. So if this graph's a line, what is this graph? A line. It's the same thing. Yes, sir?
When you do add negative ax minus c plus c.
You made one big line?
Yeah.
That's fine. You can do that. I'm separating this out for a reason. Are these equivalent to what you said? Yeah, you could have had one big line here, but I wanted to show it dividing both. You're not incorrect. It's just a little more useful this way. Because what I'm going to do with this is I'm going to say, listen, negative a over b and c over b. So remember how a over b are just numbers? They're just placeholders for numbers. So I'm going to call this a different letter. I'm going to say negative a over b, which is taking the place of like two numbers here. Why don't I just call it, I don't know, I'm just going to call it m. And this c over capital B here, again, these are just numbers. Like it's this number and this number. Let me give it another variable name. I think I'll call capital C over capital B. I think I'm going to call it small b. And then this becomes y equals mx plus b, where m represents the negative a over b, and the little b represents that. Y equals mx plus b. This is an equation that you're going to remember forever and ever and ever and ever and ever. Because that's where we're going to drum this equation into you, that one. Y equals mx plus b, that is the slope-intercept form of a linear equation. It has a special name now. Now remember, we derived it from this. So if this graphs a line, what does this do? It graphs a line. But why is this so special? Remember M?
Yeah.
M is slope. M is slope. So if you have an equation in this form, then you know the slope of the line just by looking at the coefficient of the x value. Do you know what a coefficient is? What's a coefficient? Huh?
It's a number next to the variable.
It's the number next to the variable, right? So yeah, so this will be a number. Remember, it's a placeholder for a number. And then b, well, let's think about b. If I replace x by 0 up here, if x is 0 and I solve for y, what did I just find? If you set x to the y-intercept. So if I set x to 0 here, I get the y-intercept. So b is the y-intercept. So I'm going to, remember this example I have up here? So if I want to graph 2x plus 3y equals 6, I could use the table values method, I could use the intercept method, or I could turn it into slope-intercept method by solving for y. So now let's do the same thing we just did but with numbers. So how would I get y by itself here? Subtract 2x. We're going to do that first. If you divide by 3 first, you can, but you're going to have to divide everything by 3, and it gets hard. So it's easier to do the 2x first, because what's 2x minus 2x? 0. Now you could write 6 minus 2x. However, I want it to look like mx plus b, so I'm always going to put the x term first, and then put the plus 6 here. What do I do next? Everything. I heard it. Everything, everything. So what am I getting? That's a big old 1.
Y equals
What's 6 over 3?
Plus 2.
2. What's the slope of the line? And this is your slope. And what's your y-intercept? And this is going to help us graph. Look at you guys. Alright, so we're going to talk about a little bit more here. Y equals mx plus b. M is the slope. And b is the y-intercept. So let's see if we can figure these out now. Y equals mx plus b. So looking at this equation right here, what is the slope of this line if I were to graph it? 3. Now what is the y-intercept? 4. How are you getting this? We're comparing it to this y. I hope you guys are listening over here because here's something else going on there. See how they compare? M is the 3 and b is the 4, and this slope, this is y-intercept. Now y-intercept is a point, right? It's a point on a graph. How would I write the y-intercept in xy form? 0, 4. That's what this represents. The 4 is the y value of that y-intercept. What about this guy? I want to know the slope, and I want to know the y-intercept. What is the slope? No. Why is the slope not 3? Hey, wait a second. You just said the slope is the number in front of the x.
Yeah.
Why is the slope of this line not 3? Compare it to y equals mx plus b. Does it look the same?
Oh, why?
You always have to be in function form. You always have to be y equals. Is this y equal form?
No.
What do I need to do?
Minus 3x and then do minus 3x plus 2.
Okay. So I've got 3x minus 3x plus y. That's just y. I could say 2 minus 3x, but I'm going to write it as negative 3x plus 2 because then it looks like y equals mx plus b. What is m? And what is b? So be careful. Again, I want you out of autopilot mode. She said it's always the number in front of the x, so I'm always going to just take the number in front of the x. I want you always thinking. That's what you guys do in your brains. It's what you do. You did bring your brains today, Cole, am I right? Are they there?
You should be a
Are they in there?
You should be a math rapper.
There are many things I should be, that is not one. Okay? All right. How about this one? What's the slope of this one? You ready? No. What's the slope? I don't know yet, right? What should I do to this guy? Solve it for y. So what am I going to do first, Ben?
You're going to subtract 3x from 3x on both sides.
Okay, so let's do that. 3x minus 3x, right? That's gone. What's left here? I could write it as 12 minus 3x, but I am going to put the x term first so that when I'm done, so my slope is negative 3, right? Nope. Oh. Yeah, is this say y equal yet? No. So what do I divide by, Ryan? And what gets divided by negative 3? All right, now I got to do some reducing here. That's my big old 1. That's good. What's negative 3 over negative 3? 1. So how many x's do I have? 1 x. Do I need to put a 1 here?
Nope.
Not really. What is, careful now, positive 12 over negative 3? 4. Okay. What is my slope? What is my y-intercept? So I know there are people who are saying this. Is everybody saying this? Is anybody sitting here going, oh, what is she doing? Anybody? Yes. She's out here. What? What'd you just do? Ladies and gentlemen, shush. Question. I solved for y. You're always going to solve for y. And this is what we did last unit. Solve, so I subtract 3x from both sides, right? Negative 3y, yeah? Then I want y by itself. Divide everything by negative 2. That gives me a y. Negative 3 over negative 3 is 1x. There it is. And plus 12 over negative 3 is minus 4. Now I'm in y equals mx plus b form. So y equals mx plus b. So this m, I don't see what's here. There's really that 1 is there. So that's your slope. And then plus b, well, that's plus this. So that's your b. We're going to do a few more of this, okay? So please stay with me.
I get it.
All right, we're going to do a little graphing calculator activity, which is why I gave you that other paper. So now you can take up that paper, slope intercept activity. And listen first. I want you to get an idea of what slope and y-intercept, excuse me, what slope and y-intercept, what changing those values will do to what a line looks like. Because if you kind of understand that, you're already going to have a feel for, oh, here's an equation I need to graph. I kind of think I know what it's going to look like. So if you look on the bottom, there's some conclusion questions. They're this. How does changing the value of slope affect the line? And what happens if you have a big slope number versus a small slope number? And also what happens when you change the value of b, which is the y-intercept? What does that do to what your line looks like? Okay, so we've got this paper here. I'm going to make this a little bigger so you can see it. And so at first we're just going to kind of follow along together here. So you need your graphing calculator. And we talked about this a little bit. Turn it on. You can clear it out if it's not clear. I'm going to clear mine out. Okay, second plus that 1, 2. What I want to do is I want to graph y equals x on here. So you go to the very top row where it says y equals. Everybody's doing it. And you're going to press that button. Everybody's doing it?
Yes, we are.
See. You got a calculator? Right, okay, get that one. I want you to do it. For graphing the y equals x, I want to show you how to do it. Top row, press y equal. Are we all there?
Yes.
Yes.
So, what? No?
Yes.
Now the beauty of this little graphing thing, please stop talking while I'm talking. If you have a question, raise your hand. These all must be solved for y. If you want this graphing calculator to graph something for you, it always has to be y equal. So if you ever want to use this thing and you have an equation, it's not y equal 4, you're going to have to put it in y equal 4. So I'm going to start with y equal x. Do you guys remember where the X is? Where is it?
It's the one next to the.
Yeah, you'll look for this alpha button. Don't press it. Just look for it, and then go one to the right. And if you press that, you should get an X. Everybody finding that?
Yes.
Okay. Now I want to graph it. So I'm going to go all the way to the right on that top row where it says graph. Press it. Now, if it's looking wonky or funny, there's a zoom button, which I wish I could see where it is. The zoom button is right here. It's the third button in. And if you say zoom number 6 for standard, sometimes they do get little funny things. If you're having trouble seeing your graph, try that first. Zoom 6. But that's what y equal x looks like. So what we're going to do with that is this a positive, negative, 0, or undefined slope? Y equal x. It is positive. So in this little table here, I'm going to write the word y equal x right in front of it. You might want to do that too. It is a positive slope. Now let's think about what the value of m and v is. How does this compare to y equals mx plus v? What's m? 1. M is 1. Yeah, the slope. And what is it for y equal x? Yeah, there's an invisible 1 in front. Your slope is 1. What's b? What's the y-intercept? Yeah? 0. Because that's a 1x plus a 0. And this is y-intercept, right? Let's look at the graph. Is the y-intercept 0? No. Okay? Now, I want you to sketch this graph. So you go to the back, and you're going to pick one of this, and I'm going to write y equals x here. So you told me the slope was 1, and the y-intercept was 0. So y equals 1x plus 0. That's this one. And sketch the graph. What does it look like? And I'm just, well, it's a line tilted like this, right? It looks like a perfect diagonal to me. So I'm going to graph that on the calculator, or from the calculator onto this piece of paper here. Okay, that's on the back. Okay, so you sketch a graph. You do the best you can. You look at the picture on your calculator. Say, I want to make it look like that. Yeah. Which numbers?
Random.
They're not random. What do you mean?
No, like.
The 1 and the 0?
Yeah.
That's not random.
No, like I know the answer, but like where did you get like y equals x? So like they give you
Oh, I'm going to give you different values to graph, right? So if we graph y equals x, I want you to now graph y equals 2x. So what I want you to do is go back to your calculator here, press y equal. I guess we could keep our y equal x in here. Go down to y2 equals. And I'm going to put a 2x. Okay? 2x. So before you press graph, what's going to happen is you're going to see the first thing is going to be y equals x. And then it's going to graph y equals 2x. You have to kind of watch closely. What happened? Are we there? What's the matter? Now when you press graph, so you can look up here first to make sure you see the same thing. There's my y equals x. Y equals 2x comes in a second. And the second one you see. This one's y equals x. This one is y equals 2x. Now I am going to make a note of what I had here. This one was y equals 2x. What's my slope for y equals 2x? And what's my y-intercept? Is it positive still? Yeah. And we're going to sketch that guy as well. Y equals 2x. My slope was 2, my y-intercept is that one. Y equals 2x plus 0. And this one was like higher or something, right? Steeper. Yeah, I like that word. It was steeper. It became a steeper number.
You just do this for 3, 4, and 5.
Well, okay, yeah, we're just playing now. So what I did was, this one has a slope of 1. This one has a slope of 2. What's different? I want to try one more like this, which is using a slope of a half. So I'm going to want to graph y equals a half x. And in the directions, it says to put a 0.5. I want to show you what I really want you to do when you have a fraction. So if you'll look up for a moment, just look up at the graph that I'm going to do in a moment. Everybody looking up here? Yeah. Okay, for y3, I want to graph y equals a half x. The way you put in a fraction is take a left paren. You see where the left parenthesis is? If you look above the 8, you see a left parenthesis?
Yeah.
And then type 1, a divide, oh, I need to divide here, by 2, then close that parenthesis. That's how you're telling it I want half of x. It has to be in parentheses or it's not going to be correct. This says you have half x. And let it worry about converting fractions. You don't have to convert them. All right, now when you graph it, watch what happens. Remember, you're going to see y equals x, y equals 2x, and then your new one. Here it comes y equals half x. All right, so what's happening with that one? Value of n is half. Big, positive. Now when I graph y equals half x, slope is a half, y-intercept is 0. It was, I would say, flatter.
Yeah, it was a lot flatter than the other one. It was like less steep.
Less steep.
It's like 0.
Less
No, it
steep.
wasn't.
Well, look at this. This one's y equal x. So when your slope is 1, it kind of looks like this. When y equals 2x, it's steeper. I like that word. And then when y equals half x, it is less steep. So when I think about that first question that we were asking, how does changing the value of m affect the slope, affect the line itself? So what happens when you have a big number? What do you think is going to happen if y equals 5x? Let's see. Yeah, let's see. We think it's going to get real steep. Let's try it.
Oh, it's going to be
Well, I'm going to try 5x. I think it's going to be steeper. Look at that.
Oh, God.
Now what if I do y equals 1/4?
less steep.
Yeah, let's see.
Oh, the second one? Are we supposed to keep doing
Yeah.
this?
Well, you can just look up here. I want to see what 1/4 x looks like. Look at that. Here it comes, here it comes, here it comes. Now think about this. What does y equals 0 look like? Nice flat line. So as I get my slope closer to 0, what's happening? Getting closer to that straight horizontal line, isn't it? Now as my number gets bigger, I get a steeper line. So how does changing the value of n? What happens when you put a big number in for slope? What kind of line are you going to get?
Steeper.
Steep. So big number slope. That means steep line. Right? What happens if you have a small number slope? It's less steep. I like these ones. You guys are doing a good job today. The thing you have to be careful of, slope is a magnitude. What happens if these are all negative? I don't know. Does it change? What's going to happen with
It's a negative. It's a negative. It's a
Yeah,
it's a
it
negative.
flips it. What? So if I just put negatives in front, I'm just going to put negatives in front and just see what happens here. I cannot see. All right, let me look over here where I can see. There's my insert key.
Oh,
Insert a negative. All right, you're probably doing this faster than I am. Oh. I'm going to just get rid of these other ones just because I'm having a little trouble. It does flip them, you're right. But that steepness applies. So negative or positive, if the number itself is big, 2 and -2 is really the same thickness or steepness, it's just reversed. Okay? So that's cool. I want to look now what happens if you change the value of v, the y-intercept. So we're going to go back into y equal, and I'm going to get rid of this negatives here. All I want you to do is add 5. Add 5 to, let me think about this. Yeah, I'm going to keep one y equals x and make one y equals x plus 5 and graph it. If you want to try that, make one y equals x and one y equals x plus 5. I want to see what happens. All right. Now wait a second. Which one is the y equal x again? One that goes through 0. This one is y equals x plus 5. You say what? It shifted it left? know, we can think of it another way. Also shifted it up. How about, what do you think's going to happen if we do x minus 5?
Go
Below it? Let's say x minus 5. So what's happening is when you add a b, a positive b is picking it up along that y-intercept line, and if you subtract, it's kind of pushing it down. These are called transformations. So the other one, transformations, which you may have learned a little bit about. You know translations and stuff, Jake? I thought about that at all? Yeah, this is what this is. This is a translation up or a translation down.
Oh, yeah. Questions.
So the reason you're learning that is because when you graph, they come in handy. So let's see if we can answer this question here. What happens to the line is you change the value of b. What if you add a positive b? What happens to your line? Moves it up. However many places you add, right? What happens if you subtract a b? Another way of saying that is you add a negative b. What happens then?
Move down.
Moves down. And these are called translation. Just like you learned about these, I believe you did last year. These are translations too, but they're a little less obvious. So what do you think? So when you see something like this, y equals 10x plus 7. Without graphing it, what do you know about this line, y equals 10x plus 7? What do you know, Ryan?
It's going to be like high up.
It's going to be high up, right? We're going to be at 7, right? And what do we know? What is the slope of 10 telling us? Real steep. So it's a steep number, a very steep line pushed up to 7, up the y-axis. So that's what this is. What if you see y equals 1/8 x minus 2? What kind of a line should we expect to see?
Going down.
Well, it's going to go down too. It's still a positive slope, so the slope will be positive, but it will be flat. It will look very close to the horizontal, right? 1/8 is close to 0. What if you make it negative? What if I have this kind of a equation here?
It'll be like just
It'll
x
be a negative slope.
Negative slope. And
goes down.
moved up 2. This says move it up 2.
Oh.
And it's a little bit steeper than the normal y equals x, right? So that's our takeaway. So as you're doing graphing and stuff, it's kind of your check. If you are graphing y equals negative 2x plus 2, and your line comes out like this, are you right? If I say graph this, and you got this line, are you correct?
Yeah.
No.
No.
Can't be. Why is this not the correct representation of that?
Because it's positive.
This slope is positive. This one says it's negative. So knowing a little bit about what these numbers mean should help make the graph better. And that's why we're doing this. All right. We're moving on. We are. I think you got it. Because what I want you to learn how to do is graph with this. Because we know two kinds of graphing methods now. We know how to graph using table of values, and we know how to graph with x and y intercepts. So we should, right? This is where you make this little table, and you put -2, -1, right? You plug it back in, you get the y values, and you make those little points. What's the problem? There's nothing really other than it takes a while, and for me, it can be error prone. You don't plug them in, right? The intercepts, that's when you set x equal to 0 to find like the y-intercept, and you set y equal to 0 to find the x-intercept, and nothing really wrong with that either, except a lot of people have trouble with it. What's nice about this, and there's a whole lot of story here, is that, believe it or not, it's easier than the other two, even though this looks like, are you kidding me? Oh, watch it first. These are words to remind you after you've seen it a few times, like, what do I do next? So this is more useful after you've kind of seen it. So let's look at how to graph. So let me see. I have this example on page 2 here on the back. You just did it. It's on the back of the notes, right? I'm back on the notes. Right? Be back on the notes. You see where it says graph -2x plus y equals 3? You got that? Okay, so we're going to graph this step by step. Boom. All right, so the first thing you have to do is, wait, first of all, look at this thing. What's the slope? If you're saying -2, you're wrong. Why are you wrong? Have to put it in function form. Has to be in slope-intercept form. Y equals mx plus b. Your first step is take your linear equation and put it into y equals mx plus b form. So let's look at this guy. I want y by itself, so what do I do? Plus 2x. Both sides, right? Because -2x plus 2x is 0 plus y, you got a y. You could say 3 plus 2x, but I want my x term first, so I'm going to write it first. Okay, you do that first. It has to look like y equals mx plus b. Has to. If this is what you keep forgetting, or you've forgotten it a couple of times already, star this one. Very important. Okay? Then, tell me what the slope is, and tell me what the y-intercept is. So what's the slope? 2. And what's the y-intercept? 3. Okay, now, in this little thing here, it says in fraction form. And now you're like, okay, Miss Grieser, you told me that I'd always the simplest form. Why would I make that a fraction if it's not a fraction? And you're right. Except when I'm graphing. When I'm graphing, I'm going to make use of the ratio of change in y to change in x. Now, if your m is a fraction, you're good. Now, is this written as a fraction? Can I write it as a fraction?
2/1.
Yeah. So when you're graphing, if you have a whole number here, turn it into a fraction by just putting it over 1. If it's already a fraction, just leave it. Okay, plot the y-intercept. Well, wait a second. This is 3. Well, plotting, I need an x and a y. So what is the point that goes with this? Well, 3 over 1 is still a number. I want an xy pair. And it's a y-intercept. 0, 3. Right? You knew that, right? Okay? So what that means is plot this point. This is a point on the line. Right? We got 1. Okay? It's the y-intercept 3. It's up there. Okay, now here comes the fun part. Now, this is, okay, I see what's going on there. Let me put this through. I love this graphing method. It is fun. You're going to use slope. Now remember how we said find the slope when you were counting boxes? So we're kind of doing that same thing. My slope is 2 over 1, and that's your change in y over your change in x, right? It's a positive number, isn't it? So that means you go up. If this had been negative, you would go down. Now the change in x is left or right, isn't it? It's a positive number, so I'm going to go right. This says from every point to any other point on this line, you go up 2 and right 1. Who's with me? Alright? Right? Now you say 2 over 1 means the change in y over the change in x is you go up 2 and then you go right 1. Now if I keep doing that from this point, that's also going to be trim off the graph. I got stuff down here. So here's where understanding how negatives work. Tell me this, if I have 2 over 1, is -2 over -1 equivalent? Yeah. What's a negative over a negative? Positive. Okay. So now I still have change in y over change in x. Up, down. Negative is which direction? Up or down? Down. And now I'm doing left or right. A negative is which direction? Left or right? So watch, I'm doing this because this says you can go down, 2, and left 1. Going up and right is equivalent to going down and left. Down 2, left 1. Down 2, left 1. Down 2. Look at all these points I just found. I can connect them now. I didn't have to do one bit of arithmetic. Plugging in an x, doing a calculation, getting a y. Did not have to do any of it. Yes? Okay? So we're taking advantage of understanding this ratio, and that's why I want it to be a fraction. That's why I don't want you converting it to a decimal. That's why I don't want you making it a mixed number. You make it a fraction. I sort of kind of followed that. Let's try another one.
I have a question now.
Yeah.
Why do you use m instead of g?
M is slope, and that's my ratio. B is my y-intercept. It's a point on the graph. Okay? So So here we go. I got all my directions again. This is example A. Y equals 3x plus 2. It says put it in slope-intercept form. It already is. So I don't have to do anything with this one. It's good. What is the slope and what is the y-intercept? Slope is 3. Y-intercept 2. So what is my y-intercept point then? I'm going to plot it. 1 point done. Okay, then I take my slope, and I need it to be a fraction. Is this a fraction?
No.
So I'll put it over 1. This is my up-down direction. This is my left-right direction. Am I going up or down 3?
Up.
And am I going left or right 1? So starting at this point, your y-intercept, go up 3 and right 1. And if I had room, I would do it again, but I'm out of room. So what's the equivalent of going up and right? Yes, sir? Down and left is equivalent. So 1, 2, 3, over 1 left. 1, 2, 3, down, left 1. And there we go. This is fun. They're all fun. No, this one is that a little better? You kind of missed it the first time. Oh, coming a little bit clearer. Let's do another one.
This is so easy.
Okay. Wow. Oh no. Okay, we can do it. Deep breath in, deep breath out. We got it. Okay, so put the linear equation in slope-intercept form. Is it in slope-intercept form? No, I want y equal. So how do I get it there?
Subtract x.
So I'm getting y equals, all right, I'm going to put my negative x first, and then it's a minus 3. So it's y equals negative x minus 3. That's my slope-intercept form. Okay. Gotta find m, and you gotta find v, so be careful with this one. What is m? Raise your hand if you think you know what m is. Raise your hand if you think you know what m is. What do you think it is, Julie? Oh, close, you're so close. Look at it again, just look at it again. Negative 1. Awesome. Right? It's invisible, but there's a 1 here. Your m is negative 1. What's your y-intercept? Your v value. Negative 3. Are we okay with this part? Anybody like how? Plus negative 3. Okay, so I'm going to plot my y-intercept, which is what? 0. Now it's negative 3, so I'm going down here. Okay, now I need my slope in fraction form. Now it's negative, right? Negative 1, just put it over 1. The slope is negative. Which way is this thing going to tilt? This way or that way?
That way.
That way. Yeah, it's negative. So let's see. Change in y, that's my up and down. Change in x, that's left and right. This is a negative number. Which way? This is a positive number. So you start at your y-intercept. It says go down 1, right 1. Go down 1, right 1. Now I'm out of space. Now remember, I made a big deal about how this is the same as that. Isn't it? So 1 is now up, and this is now left. So down and right is the same as up and left. Up 1, left 1. Up 1, left 1. Up 1, left 1. You can do this all day, right? There's like no effort involved. Once you kind of figure out that pattern, I see my line. Always assume you got to know all real numbers, unless it says otherwise, so you're connecting with arrows. Always check. This is a negative line, and my slope is negative. It is very easy to kind of go the wrong way. A very common mistake is that instead of going up and left, maybe you went up and right. Happens all the time. So check. Negative slope, negative slope. Always check that. Okay. I want you to try this third one on your own. Give it a try. One thing we didn't get to, which is parallel lines. We will go over this next time. You don't have to do the question with parallel lines, but if you want to try them, the quick word is parallel lines. Please sit down. I did not tell anybody to move. Parallel lines same slope. So if you want to try the questions that ask about parallel lines, they have the same slope. But we will